Now let's take the first question. Here it says that in a triangle ABC, the median AD and BE, they are perpendicular to each other and they have the length 12 centimeter and 9 centimeter respectively. So the length of AD is 9 and BE is, the length of AD is 12 and the length of BD is 9, right? And we need to find the area of triangle ABC. So here the key point is the term median. Since the medians are known and they are also perpendicular, so if I draw the third median, we have been given two median AD and BE. So if you can refer to this figure, we are drawing a third median. So we know that the median, they intersect at a point G, which we call it centroid. And there is a property that a centroid divides the median in the ratio of 2:1, right? So CG will be 2 and GF will be 1. Similarly, BG will be 2 and GE will be 1, right? Now we have also been given that the length of AD is 12. So if I want to find the length of GD, so we know that GD is to AD, they will be in the ratio 1:3, right? Because if this is 1, this is 2, the entire length is 3. So they'll be in the length of 1/3. And we know that the length of AD is 12. So clearly by substituting the value, we'll be getting that the value of GD is nothing but AD by 3, which is nothing but 12/3 or equal to 4. So we have found that this length is 4, correct? Similarly, we need to find the length of say GB. So clearly we can see that GB over BE, this will be in the ratio 2:3, correct? Because this length is 2 and this length is 1. So GB will be equal to 2/3 times of length BE, which we have been given as 9. So substituting here, it will be 2/3 into 9. Clearly it will be 6. So this length is 6. Now if you focus on the triangle BGD, if you focus on this triangle, then we see that this is a right angle triangle. The perpendicular, if I consider this as a perpendicular, this length is 6, and if I consider this as the base, then the length is 4. So clearly the area of this triangle BGD will be equal to half base into height. On calculation, we'll be getting it as 12. Now, one more important thing about the median is that the median, if I draw all the three medians in a triangle, then it divides the triangle into equal areas. There are 6 portions, so all these 6 portions, they have the same area. This is the property of the median. Now we have already identified that this area is A, which is equal to 12. So if A is equal to 12, the total area of the triangle will be nothing but the area of this plus this plus this plus this plus this. So clearly, if I add, then this is going to be 6 of A. Substituting the value, we'll be getting it as 72. So option B becomes the right answer. I'll consider this question to be a medium, easy to moderate difficulty level. Of course, you'll need to apply the application and the theorem of median. If you know both these theorem, both are very elementary in nature, then you'll be able to solve it within a minute. Now let's take another very interesting question. Here it says that let ABC be a right angle triangle with hypotenuse BC of length 20 centimeter, and if AP is perpendicular on BC, then we need to find the maximum possible length of AP. Now if I draw the triangle ABC, which is right angle, taking BC as 20 centimeter and AP to be the perpendicular on BC, then we'll be coming up a figure like this, right? So here we can see that BC is 20, perpendicular is drawn, AP, this is perpendicular, and let us assume that AC and AB both are, the value is say A and B respectively. Now since this is a right angle triangle, we can say that A square plus B square is equal to 20 square, correct? Or we can say that A square plus B square is equal to 400. Now this is the only relation which we can figure out. We have to focus on the length of AP. Now if we figure out AP, then this is nothing but the height if we consider this length to be the base, right? Similarly, this triangle, if I consider this to be the base, then this will be the height. So for the same triangle, if I want to find the area, then I can have both ways of finding it, or I can have two different ways of finding the area. I can use this as the base and this as the this as the perpendicular. Then we can say that the area of this triangle ABC will be equal to half base into height, correct? Or this is nothing but half A into B. Or if I consider the length of AP to be say H, or let us consider it to be AP only, that if I consider this to be the base, this to be the height, the area of the same triangle ABC would be equal to half base into height, which is AP. Now both are equal. So if I can compare them, then we can say that half of AB will be equal to half of 20 into AP. So this will get cancelled out. Clearly the value of AP is equal to AB over 20. Now clearly the length of AP depends on the product AB. So if this product is maximum, then we can say that the length AP would be maximum. Now the only relation which we have is this, which we have identified by using the Pythagoras theorem. Now to find the max and minima, we'll be applying the logic of AMGM, because clearly we can see that A square and B square, the summation is given to us. And if I take the product, then definitely I'll be getting A into B. So clearly, if I consider this to be the first term, these to be the second term, then the arithmetic mean of this will be always be greater than equal to their geometric mean. So it is nothing but A square into B square. Or clearly, if I substitute the value, we can say that A square into B under root will become AB. This is less than or equal to A square plus B square by 2. We can substitute this to be 400 here. So clearly AB is nothing but equal to less than equal to 400 divided by 2, right? Or we can say that the length of AB is nothing but less than or equal to say 200. So this AB is either equal to 200 or less than that. So if I want to find the maximum value, then definitely it is going to be 200. So we can substitute here. The value of AP would be 200 divided by 20, which comes out to be 10. So 10 becomes the maximum value of AP. So option A becomes the right answer. Now in this question here, let's say that G is the orthocenter of the scalene triangle ABC, and we need to find the ratio of area of quadrilateral DECB to the area of triangle ABC. So DECB, this is the quadrilateral, and the complete triangle is the triangle ABC. So we have to find the ratio of the area. Now since G is the orthocenter, so we have to understand the orthocenter is a center which is formed by intersection. In fact, it's a point which is formed by intersection of the altitudes. So clearly here we can see that for the triangle ABC, CD is the altitude. Similarly, BE is the other altitude. So the intersection is the point which is orthocenter. Now, if you look at this question, it is difficult to identify unless we give an observation. We find by observation that the the quadrilateral DECB is a cyclic quadrilateral. It will be very difficult if you don't figure out this thing. Now, why this is a cyclic quadrilateral? So first of all, let us understand what is cyclic quadrilateral. Cyclic quadrilateral is nothing but that a quadrilateral which can be inscribed inside a circle. Correct? So this is a cyclic quadrilateral. There are certain properties of cyclic quadrilateral. What are the properties? In a cyclic quadrilateral, the opposite angles, if we add them, suppose this is alpha and say this is beta, then the sum of the angle, opposite angle, is always equal to 180 degree. This is the property. I'm not going into the derivation, but this is the basic property of cyclic quadrilateral. There is another interesting thing in a cyclic quadrilateral, and that is if we extend one of the line, one of the side, if we extend in a cyclic quadrilateral, then this angle so formed, right, on the extended line with one of the side, this angle so formed will be equal to the angle opposite to this side, which is beta here. So this will be equal to beta. This is easy to prove because it's quite simple. We can see that this is a straight line. So this angle plus this angle will be equal to 180 degree. And we know that this angle plus this angle is also 180 degree. This is a common angle. So obviously these two angles will be equal. So these are the properties which we'll be using while solving this question. Now, first of all, why this quadrilateral is a cyclic quadrilateral? The simple reason is that if I draw a circle considering BC as the diameter, let me repeat, if I draw a circle considering BC to be a diameter, then it will surely pass through these points D, E, C and B. Why so? Because we also know that there is a property that in a semicircle, the angle so formed is always equal to 90 degree. Here we can see that if I take all these 4 points and draw a circle such that these 4 points lie on this circle, then clearly B, D, C, this is a 90 degree, right? Because the converse is also true. If the angle is 90 degree, then definitely if I draw a circle or a semicircle, it will pass through all these 3 points. The same thing is for E also, right? Because E is also 90 degree. So we can be sure that all these 4 points will lie on a circle, and hence the quadrilateral is a cyclic quadrilateral. So if I consider this angle ADE, let me assume it to be theta, then this angle will be equal to angle opposite to this side for the quadrilateral. So obviously this will be equal to this entire angle, which is equal to theta, right? Now, if I consider triangle ADE and another triangle ABC, in fact, what I should be doing is that I should be writing it like this, that the triangle ADE and triangle ACB, clearly we can see that these two triangles are similar. Why? Because angle A is common, right? Angle D is equal to angle C, which we have just proven by this particular property. So the third angle will definitely be equal. So we can say that all three angles are equal. So using the property AAA or AA only, we can say that these two triangles are similar. Now we know that for a similar triangles, the ratio of area is equal to ratio of square of their corresponding sides. So what are the corresponding side? The corresponding side AE, the corresponding side will be equal to AB. So we have been given the length of AB to be 8 and the length of AE to be 4. So clearly, so if we take the ratio of area of triangle ADE over triangle ACB, then clearly it is nothing but AE over AB whole square. This is nothing but 4 by 8 whole square, which comes out to be 1 by 4. So 1 by 4 is the ratio of the triangle ADE and ABC. But we have to find the area of the quadrilateral DECB. Clearly, if I consider that the area of triangle ADE is to be A, then the complete triangle ABC, the area would be what? 4 of A. And if I consider this quadrilateral, then this quadrilateral is carved off out of the triangle ABC, out of which this portion is removed. So clearly we can say that this area would be equal to 3A, right? So now if I want to find this ratio, then the quadrilateral is 3A, the area is 3A, and for the complete triangle the area is 4A. So the answer has to be 3 by 4. So option C becomes the right answer. Now here the question say that x, y, and z, they are three ants who are moving at a point, who are at the point A, B, and C, and they start crawling at the same time with equal and uniform speed along the perimeter of the triangle ABC in the anti-clockwise direction. We need to find the distance of y and z when x has reached point B for the first time. Now the situation is given here. We can see that this triangle, the length are 3, 4, and 5, and it's a triangle. Obviously 3, 4, and 5, this is a triplet which is following Pythagoras theorem, Pythagoras triplet basically. So we can say that this triangle itself is a 90-degree triangle. We can easily prove it by applying Pythagoras theorem, that this square of this is equal to sum of the square of these two. It only happens in a right angle triangle. So obviously this angle is a right angle triangle. Now, since the speed is uniform and they are moving in anti-clockwise direction, so A will be moving or X will be moving in this direction. That is, X will be moving from A to B. Obviously, if the speed is same for all three, if X is moving from A to B, the moment X reaches at this point, it would have moved 3 meters. At the same time, Y would move from B to C and will be 3 meters away from B, and it will be somewhere here. Correct? So clearly this entire length is 4, so this length would be 1 meter. Similarly, Z will also move 3 meters. Suppose Z has reached at this point. Correct? So this length would be 3 meters and this length would be 2 meters. Now we need to find this length, that is Y and Z. Now we have to drop a perpendicular from Z on the line BC. Let it be 90 degree. Why we are doing so? Because if I assume this to be point E and this to be point F, then we can say that triangle ABC, this is similar to the triangle EFC. Why so? Because both are 90 degree and this angle is common. So two angles are equal. So obviously the triangles are similar. Now to figure out the length of E and say this point is say ED, then we have to find the length of EF and find the length of FD, so that we can apply Pythagoras theorem in this triangle to get the length of ED. So we have to focus on the length of ED. So if we want to figure out the length of EF, this length, then we can say that because these triangles are similar, then AB over EF, this would be equal to AC over EC, and this would be equal to BC over FC. right? Now, a point to note here is that the length of EC, this length is 3 meter here, and in this triangle, this length is 5 meter. So clearly, EC and AC, this basically is equal to 5:3, correct? And we know the length of AB, we know the length of BC, so we can clearly get the length of EF. If I compare this with this, then we can say that EF is nothing but 3 by 5 times of AB, and we know that the length of AB is 3 meters, so obviously this is 9 by 5. So we have identified this, right? So this is done. Now what about FD? So for FD, what we can do is that we can find the length of FC. So the length of FC, we have to focus on this. So if I compare this with this, then we can say that FC is nothing but 3 by 5 times of BC. The length of BC is 4. So obviously it will be 12 by 5. Now this entire length is 12 by 5, this much length, right? This much length is 1 meter. So obviously FD, we can say that FD is nothing but FC minus DC, which is 12 by 5 minus 1, which is equal to 7 by 5. So we have identified both FD and EF. So applying Pythagoras theorem here, we can say that ED square will be equal to EF square plus FD square. Now EF square is 9 by 5, so it will be 81 by 25, and here FD is 7 by 5, so it will be 49 by 25, right? On addition, I'll be getting it as 130 by 25, so we can reduce it by 5, so we'll be getting it as 26 by 5. So this is ED square. So the length of ED would be what? Taking the under root, it will be under root of 26 by 5, which is option number C. This is not a very difficult question, but of course it is a lengthy question. We can easily identify by that we have to apply a similar triangle here, because the moment we come across a slant height, we have to create a right angle triangle, and this construction of right angle triangle itself will give you the direction that we have to apply similar triangles here. Of course, lengthy but not very difficult. I'll rate this as a moderate level of question. Now in this question, we have been given that the triangle ABC is an isosceles triangle with the length AB is equal to AC. Similarly, AE is also equal to AF, and the angle BAE is 30 degree. We need to find the length of angle FEC. Not a very difficult question, can be solved easily because we have to apply that in an isosceles triangle. If the sides are equal, then angles are also equal for the same side. So here the diagram is already given to us, and the angles are also marked. This is not the part of the question, but we have done it. So if this angle is x, then this angle is also x. Similarly, for this triangle, since these two lines are equal, then definitely this is y. So this is also y. Now, if I just consider this triangle FEC, then we can say that we have to identify this angle. Say this is theta. Now this is an exterior angle for this triangle. So we can say that y would be equal to theta plus x, or we can say that the value of theta is nothing but y minus x. So somehow if I can get the value of y minus x, I'll be getting the value of theta. So let's focus on that. Now let us take the triangle AEF. So in triangle AEF, what we are doing is that the length of all these three is equal to 180 degree, or we can say that the length of y plus y, that is 2y, the sum of these two should be equal to 180 minus z. So 2 of y is equal to 180 minus z, right? This is of course in degree. Say this is equation number 1. Similarly, considering triangle ABC, we can say that sum of these two must be equal to 180 minus this entire angle, right? Or we can say that 2 of x must be equal to 180 minus 30 plus z. Say this is equation number 2, or let me just reduce it like this, that this can be simplified at 2 of x is equal to 150 minus z, and say this is equation number 2. Now we are interested in getting y minus x. So obviously let us subtract the second equation from the first. So obviously this z will get cancelled out, and we'll be getting 2 times of y minus of x is equal to 180 minus 150, which is equal to 30 degree. So the value of y minus x is equal to 15 degree, and that is nothing but equal to theta. So option A becomes the right answer. Not a difficult question, very easily can be solved. It should not be taking more than a minute. Now in this question, it says that AB is a chord of the circle with center O. C is a point on the circle such that the angle formed ACB is 30 degree. Now if the length of AB is 4, then we need to find the largest area of triangle BOC, right? So if we draw the scenario, then this is the circle. Say this is the chord AB and this is the center O. Now it says that C is some point here, maybe, such that this angle ACB, so this angle is 30 degree, right? Now we have to find the area of triangle BOC. So let us join CO and OB. Simultaneously, let us also join AB, so that OA, OB and OC all become the radius, right? So this is equal, correct? Now we know that if this angle is 30 degree, then the angle formed at the center would be double of this, which is 60 degree. So if you focus on triangle AOB, then we can say that this is an equilateral triangle. Why? This angle is 60 degree, both these sides are equal, so obviously we can say that these two angles will also be equal. So if this is x, then the sum of all these three, that is x plus 60, should be equal to 180 degree. Thereby we'll be getting the value of x to be 60 degree. So all these angles are 60 degree. Now let us take that this angle is 30, say theta. Now this is also equal to be the radius. The value of AB is 4. Now since this is an equilateral triangle, so we can say that the radius is also 4, because this is equal to this is also equal to this, because this is an equilateral triangle. So you can say that the radius is 4. Now if you look at triangle BOC, if the including angle is theta and the two sides are given, that is in any triangle, if we have this angle theta and if these two sides are given, then the area of triangle is given by half AB sine of theta. So here again, here also we'll be applying the same logic. So both A and B are equal to 4. So we can say that the area of triangle BOC is nothing but half 4 into 4 into sine of theta. Now we have to get the maximum value of this. So the maximum value of this will depend upon the maximum value of sine of theta. And we know that this is a very elementary trigonometry, that sine theta, the maximum value is 1 when the value of theta is equal to 90 degree. So clearly we can say that the max area of this triangle BOC will be equal to half 4 into 4, where the sine theta is equal to 1. So the answer would be A. So option D becomes the right answer. Now this is a very interesting question. We can apply the logic of similar triangle here. Now why we will be applying similar triangle? The reason being, it is given that these lines are parallel. So if the lines are parallel, we know that if the two lines are parallel, and if I draw a transversal, then definitely these angles are equal. Similarly, this and this angle is also equal. So we'll be getting more equal angles. And if the triangle is so formed, the angles are equal, then definitely it is indicating that we have to apply similar triangles, the logic of similar triangles. So let's proceed. So here we have been given that P is a point, any point inside the triangle ABC, and the three line segments which are parallel drawn through P, they are parallel to the side AB, BC and CA. So this line is parallel to AB, this line is parallel to BC, and this line is parallel to AC. Correct? Further, the area of the three triangles, that is DPG, this area is 1, this area is 9, and this area, this area is 25 in fact. This is 9 and this is 25. Now we need to find the area of the triangle ABC. Now here we can see that if we find that these two lines are parallel to each other, then we can say that this angle would be equal to this angle, right? Because in a parallel line, if a transversal is drawn, then these two angles are always equal. Corresponding angles are equal. Fine. Similarly, we can say that if these two lines are parallel, then this angle is equal to this angle, right? And since this is parallel to this line is parallel to this, so this angle will also be equal to this angle, with the same logic that they are corresponding angles. So from here what we have seen is that in fact let us proceed ahead. If these two lines are parallel, then definitely this angle and this angle will be equal. And one more thing which we have to do here is that say these two lines are parallel, so we can say that this angle and this angle will also be equal. So here what we have seen is that in all these three triangles, in all these three smaller triangles as well as the larger triangles, the two corresponding angles are equal. So we can say that all these triangles so formed are similar to each other, right? Now if they are similar, then we can say that their area will be in the ratio of under root of their corresponding side. So if I assume that this side is x and this side is y and their area are in the ratio 1:9, then we can say that x over y should be in the ratio of 1/9 under root, which is nothing but equal to 1/3. So we can say that y can be replaced and be written as 3 times of x, correct? Now similarly, if I compare these two triangles, they are also similar, right? Now if the area is 1 and the area is 25, let me assume it to be z. Then clearly we can say that x over z should be equal to under root of 1/25, which comes out to be 1/5. So the value of z is nothing but 5 of x. So we can replace z and write here as 5 of x. Now further we can see that this quadrilateral BFPE, if I find this, then this is nothing but equal to parallelogram. Why? Because this angle is equal, this angle is equal, or we can say that these two are parallel, that opposite sides are parallel. Here again the opposite sides are parallel. So what is parallelogram? If the opposite sides, both the pair of opposite sides are parallel, then this is a parallelogram, and in parallelogram the opposite sides also become equal. Thereby if this is 3 of x, then this also becomes 3 of x. Similarly we can say that this is also parallelogram because this is parallel to this is parallel to this. So obviously CGPH, this is also a parallelogram. Thereby if this value is x, then this is also equal to x. Now we know that triangle DPG, this is similar to triangle ABC, correct? Why so? Because this angle is equal to this angle, and angle in fact we can find out this angle also. This angle will be equal to this angle. The reason being that this is equal to this. Why so? Because this is parallel to this, right? These are two parallel lines, so these two angles will be equal. So their area would be equal to ratio, or their ratio of their area would be equal to ratio of their corresponding side, the square of the ratio of their corresponding side. So if I just remove this, then we can say that area of triangle DPG over area of triangle ABC, they will be equal to, the corresponding sides are x and this much, right? This is nothing but 3x, 5x and x, which is 9 of x. So this will be equal to x over 9 of x whole square, which comes out to be 1/81. Now we know that the area of triangle DPG is 1, so correspondingly the area of triangle ABC would be what? 81. So option A becomes the right answer. Very good question, because it is basically challenging you to apply the logic of similar triangles, apply the basic concept of parallelogram, identifying that the quadrilaterals will form each parallelogram, so on and so forth. So obviously it's challenging, but concepts are very elementary in nature. Now let's take another question. Here it says that the base of the triangle is equal to the perimeter of the square whose diagonal is this. So if we have this triangle like this, then it says that this, if this is the base, say ABC, then this length is nothing but perimeter of square whose diagonal is this. Now we know that if I draw a square like this, then this is the diagonal, right? And if this is 7 root of 2, clearly we can see that this value would be 7, this will be 7, this will be 7, and this will be 7. Because if this value is a, then this diagonal is a root of 2. So clearly the value of a is equal to 7. So the perimeter of the square in this case will be what? 7 plus 7 plus 7 plus 7, which makes it to be 28. So this value is 28. Now we need to find the area. For that we need height, and some information is given about the height as well. It says that the height is equal to the side of the square whose area is this. So if I take a square whose side is a, then the area is a square, which is equal to 169. So the value of a would be under root of this, which is nothing but 13. So this is the height of this triangle. So we know the height, we have the height and we have the base. So obviously the area would be half base into height, which comes out to be 182. So 182 becomes the right answer. Now let's take the ninth question. Here it says that in the figure below, choose point D on BC so that triangle ACD and ABD have equal perimeter. So let's take a point D here, right? So that this triangle and this triangle have equal perimeter. So let us assume that AD is equal to X and CD is equal to Y. This entire length is 5, so this length would be 5 minus Y, right? Now, since the perimeter is equal, so perimeter of this triangle would be 3 plus x plus y, and here the perimeter would be what? X plus 4 plus 5 minus y. Clearly x will get cancelled out, right? So we will be getting 2y is equal to 6, or the value of y is equal to 3. So let us substitute it here. So we'll be getting 3 in place of y, and this will be 2. Here it is 3 and here it is 2. Now we have to find the area of triangle ABD. Now this is much easier now. The reason being ABD and ACD both have the common vertex. The base is in a straight line. So obviously point D is dividing the base in the ratio 3:2. Correct? So this area would be 3 of A and this area would be 2 of A. And the total area would be 5 of A. Right? And total area is nothing but area of the triangle ABC, which is nothing but half base into height, which comes out to be 6. So the value of A is what? 6 by 5. So the area of ABD is 2 of A, which comes out to be 12 by 5. So option D becomes the right answer. Very simple question, easy question, but a good question. Must be attempted in the set. Now let's take the 10th question. Here it says that we have to consider a triangle ABC such that BC is equal to 12, DB is equal to 9, and CD is equal to 6. And this angle is given. So this is giving us a hint that we have to apply the logic of similar triangle, because one pair of angle is equal and we have to find a common angle. So angle BCD, this angle, say theta, is equal to angle BAC theta, correct? Now we have to find the ratio of perimeter of ADC and BDC. ADC. So we have to find this value and this value. So assuming it to be x and y, we have to find the value of x and y. And BDC. For BDC, everything is known. So we have to just focus on getting the value of AD and AC. Now, first of all, we have to prove that which two triangles are similar. If I consider ABC, triangle ABC, then this is similar to triangle CBD, right? Because angle A is theta, which is correspondingly angle C is theta here. Angle B is common, and angle C will be equal to angle D. Angle C in the next case, it will be this entire angle. This entire angle will be equal to this angle. Now, since we have to focus on AD, now to get the value of AD, we have to focus on AB. So let us take AB here. So AB over, say, BC. This will be equal to BC over BD, right? So the value of AB would be equal to what? BC, which is equal to 12. So it will be 12 into 12 divided by BD, which is equal to 9, which comes out to be 16. So if this is 9, the entire length is 16. So this has to be 7. So we have got the value of X. Similarly, let us focus on getting the value of AC. So for AC, let us take AC over AB. And here we'll be taking CD over BC. So the value of AC would be what? AB, which is nothing but equal to 16, multiplied by CD, which is equal to 6, divided by BC, which is 12, right? So this will go by 2 times. This is 8. So this value is 8. So everything is known now. So the perimeter of ADC would be 7 plus 8 plus 6, which comes out to be 21. It will be 9 plus 12, which is 21, plus 6 is 27. So this will be the ratio. On simplifying, we'll be getting it as 7 by 9. So 7 by 9, whichever is the option, should be the right answer.